Okay. Hello, small class for today because we have the end of texture to do, and I told people in Piazza that they can watch this later on, and then we're not going to take attendance in class today. So since there's no attendance in class, I can see that 10 people like live, and the rest of the people would rather watch the video afterwards for today's short class. So I'm going to continue with Mipmapping, and then we'll continue through the rest of the topics. So Mipmapping was introduced in this paper in 1983, and as a general idea for dealing with minification. So the idea is we're going to store, for each texture, we're going to store reduced copies of those textures in smaller sizes. And since we have red, green, and blue, those can be stored in only 30% more space. So we can store these things. So it doesn't take up very much additional memory to store these things. So here's another visualization of the same thing. So here's our high resolution texture, and then we average together 2 pixels to get the next lower, and average together to get the next lower, and average together to get the next lower. By the time we're in the last level of the pyramid, we're down to just a single color for this whole texture, which is an average of the whole thing. So what does this get us? So if we start at the 0 level, meaning our original texture map, we have lots of detail for our front objects, but our back objects are going to get aliasing. As we step up in levels, what we end up with is blurring in the front, but okay rendering in the back. Now, why does this happen? Well, we're up several levels in the texture map. So we've now moved up to, say, level 4 or level 3, something like this in the texture map. So close up, of course, this thing got blurry. We threw away the details. But further back, we don't have those details causing us aliasing. So how are we going to figure out which mipmap level to be in? Well, our rasterizer has access to all the pixels. So as we're stepping through our triangle, going to each pixel, we can look at the neighboring pixels and we can see where do they map into texture space, right? Because the U and the V are texture coordinates, which are getting passed into the fragment shader. So we can know where those are at. We can find out where do they go in the UV. So the graphics card is doing this. This is not something that we're going to do directly in our code. And so for this pixel, we can see that they're more closely spaced. And for this red pixel, we can see them more further spaced, and we could actually be missing data, which was in our texture map over here. So we can do a little calculation based on the neighboring pixels, and we use 4 neighboring pixels, and we calculate some average size. And this is going to tell us which level of the mipmap we need to end up in. So here's a visualization. Close up, red is in some top level of the mipmap. And as we go back, we end up at different levels of the mipmap, depending on how the object is projected and how far away it is and what size the mipmap was. So we're actually going to look up from multiple levels. So we had bilinear interpolation before. We're now going to have trilinear interpolation. So we can do a bilinear interpolation on level D+1 of the mipmap and bilinear interpolation on level D of the mipmap. So remember, as we go up levels, we have less texture information. That's why these pixels become bigger, these texels in the texture map. So we interpolate to here, we interpolate to here, and then across the 2 levels, we interpolate to the middle. So it's just another level of interpolation. So here's a picture I think that may help. So we have a single pixel. This pixel projects into the texture someplace, and we can figure out that, oh, it's about 9 pixels is covered by 1 pixel on the screen, or 9 texels in the texture space is covered by 1 pixel on the screen. So we go to our mipmap. Well, we don't have a level 9:1, but we have a level 4:1 and a level 16:1. So we can go look up this color in the 4:1 level, look up this color in the 16 level, and these are bilinear interpolations potentially in each place. And then we're going to interpolate those 2 and get the final color to stick into this pixel. So here's an image that we wish that we would get. And then here it is with using a mipmap. Now notice in the back here, there's blurring. I'm going to flip back and forth a couple more times. So here's what we really wish we were getting. Here's what we got with the mipmap. So why is this happening? Well, this is happening because we're just approximating averaging the right pixels together. We're not averaging exactly the right pixels. We're just kind of taking the right region and blurring a bunch of pixels together. So of course we get blurry in the back. We can do better, and we'll talk about that in a little while. So I want to show an example of what this looks like in video. And I'm not sure, is it going to play better in video or is it going to play better with a GIF? So I've recorded it both ways so that I can try to show you. So here we have a video. And it's screwed up in the beginning, but we can see. We'll hopefully it's going to repeat around here. So now we have Mipmapping on. Okay, here's our bunny with lots of texture on our little blocks. And down here we can see that there's aliasing that's happening. And when we switch to Mipmapping, that's mostly gone. But when we zoom in, we can see the texture is still there. So this is what Mipmapping gets for us. I'm going to switch to my next slide where I have this thing as a GIF, and we'll see if it's going to work better as a GIF than it worked as a video. So we're seeing the same aliasing. This is the same thing recorded. Switch to Mipmapping, and now we're in Mipmapping. And of course it's blurred. I don't really see the texture. I just got this average gray value. But when I zoom in, okay, my texture is back. So this is the kind of effect that we hope to miss from using Mipmapping. We don't want to have this weird stuff going on when our object is animating. Okay, so let's take a look at some still images of this and say what are the different things that we had to do in order to improve the look of our textures. So if we have this is our original texture image here. And if we don't turn on any extra features, we render our texture on a plane going back, we might get a picture like this one here. So up close, we're going to have jaggies, right? So this is where for each pixel, it's a tiny little region on the texture. So lots of pixels on my screen map to one little pixel in my texture, which was gray, and I can see that texel in my texture right here. And in the back, we see this noisy pattern, and this is happening because the texture is getting shrunk down too small. So in the back section, our texture was too big relative to the number of pixels. So if we turn on both bilinear filtering and Mipmapping, we're going to smooth out our jaggies in the front through the bilinear filtering, and the Mipmapping is going to correct the situation in the back. Now these can be turned on and off separately. When we talk later about the code, you'll see the minification and magnification features that can be set. If we turn on magnification for bilinear filtering, we get this, but we don't necessarily have to turn on any minification filtering, so no Mipmapping. So then we haven't fixed the back. And you could do the reverse. You could turn on Mipmapping and fix the back, but keep using point sampling in the front. So these are settings that you can set in the way that your texture is handled.